Hello, ladies and gentlemen. It's good to be back with you again. This is Dr. Skinner, and this is chapter 13 of the SAD class. And today we are moving into, at last, system implementation. So we've done planning, we've done analysis, we've done design. We've spent a long, long time in each of these areas. And now we're actually going to implement everything that we have designed and come up with in our previous rounds. What are the things we're going to learn today? Well, let's look at this. Our learning objectives describe the process and deliverables of coding, testing, converting an information system. We've got 4 installation strategies that we need to be aware of. Each of these are different and each have their pros and each have their cons, but we've got to have an understanding of them. We have direct, parallel, single location, and phased. And then we're going to talk about what's involved in documenting a system and training and supporting our users during this process. Okay, so there's a lot going on. Coding, testing, installation, documentation, training, and support. You think about implementation and you think it's kind of like, oh, I'm just going to build an environment and put it into place, right? And it's not. You know, we've got to think about the software, we've got to think about the hardware, we've got to think about our users. We've got to make sure that we're actually capturing and building what we've designed, analyzed, and planned beforehand. We've got to provide training to our users. We've got to provide support for the whole process and so on and so forth. Okay, as you will perhaps be not surprised, right? It's the second most expensive and time-consuming phase after maintenance, and it's not just pure mechanics. Okay, it's about people. It's about the people in the organization. Okay, so what are we trying to do in the implementation? Here it says we're converting the final physical system specifications into working and reliable software and hardware. We're also doing the documentation and support, and we're going to help current and future users with our documentation. The thing to note about this kind of process, there are no sure recipes to follow that guarantee success. Okay, you kind of got to be attuned to the organizational context. You've got to think about history. You've got to think about politics. You've got to think about environmental demands. If you ignore all those, if you don't think about the culture and the history and the politics, the chances are you're going to increase the threat of failing. Okay. So what are our deliverables? We've got deliverables for coding, testing, and installation. We've also got our deliverables for documenting the system, our training, and supporting users. So coding the process. This is the process whereby the physical design specs created by the analysis teams are turned into working computer code by the programming team. Okay, so once coding has begun, testing then begin. We then go to installation. So this is the process during which the current system is replaced by the new system. We then need to think about documentation. We're thinking about documentation. It's very important for future maintenance, right? So we're thinking about our future users more than our current users when we think about documentation. And then we need to give support to the team and to our user community. Okay, so we've got to think of our strategies for training users, supporting users, giving them documentation, as well as also doing our coding, implementing our coding, doing our testing, and installing the new system. When it comes to testing, we have various approaches that we can think about. We've got to come up with our test plan. So from a test plan perspective, what are we trying to do? Well, you've got to remember that software testing begins very early on in the system development lifecycle. You know, analysis, design, master test plan, design, develop a units test plan, integration test, and system test plan. All these previous tests and test plannings that we've worked on previously, we're now going to implement them. Okay, so when we get through to doing our testing, we are going to have people who are going to be doing the testing. We're going to, as a result of having our test plan, we're going to improve the communications. That's the whole point of our test plan. We're going to improve the communication between everybody involved in testing our new environment. Okay, we're going to make sure that all the tests that we follow all kind of hang together, so that the whole big plan for all our different types of testing hang together in what we call our master test plan. So our master test plan, this collection of documents whereby each individual component of our system is a complete test plan in and of themselves. And we're going to bolt it all together and very slowly build up and build up all the components joined together. So at the end, we have confidence that we have tested absolutely everything we need to do. If you look at table 13-3 on page 458 for an example of a master test plan. So the way to think about a master test plan is almost like a project within a project, you know? So it's just a project of testing. We have to have confidence and trust that everything that we've come up with so far is tested to the nth degree so that we know that once we go live, it's going to do what it should do. And some organizations, when I worked in Merrill's and Bank of America, we actually had dedicated testers whose job was to test. Boy, were these girls and boys very good at what they did. There are different types of tests that we can do for a new environment, and they can be organized in different ways. Okay, so we have different types of tests organized in different ways. Here we see two different ways to organize them. We can either do a static test versus a dynamic test. So a static is where the code being tested is not actually executed, we're just testing the code. Or a dynamic test where the code we've written is is executed. Okay, so we have static versus dynamic. We can also have automated versus manual. Okay, so automated, the computer conducts a test. Manual, we've got people conducting the test. So as you can understand, we've got 4 permutations, right? We can have static and automated, static and manual, dynamic and automated, and dynamic and manual. So static and automated, so code being tested is not executed, but a computer conducting the test. This is like checking for syntax. A static and manual, so code being tested is not executed and people conducting the test, we can do inspection of the code. Dynamic and automated, so code being tested is executed by a computer. This might be a unit test or an integration test, and we'll get to all these little tests in a little while. And then a dynamic and manual test, the code being tested is executed by people. This might be a walkthrough and desk check by the users that everything does what they should be doing. Let's look at these in a little bit more detail, these different types of tests. So there are 7 types of tests that we're going to talk about. We can have inspection, walkthrough, desk checking, unit testing, integration testing, system testing, and stub testing. Let's look at these each in turn. So inspection, this is all manual, remember. So participants examine program code for predictable language-specific errors. We're looking at the software, we're looking at the code, okay? It's a formalized process, it's a group process, looking for those subtle errors that an automated inspection software probably wouldn't find. What the code does isn't actually that important, right? What we're looking to do is find well-known errors, yeah? And we're going to find up to 90% of all the software defects as a result of this formal manual inspection. And we're going to give this feedback back to our programmers. The next type of test we can do is something called a structured walkthrough. Okay, so structured walkthrough, this peer review of any product created during the systems development process, including the code. This time, what the code does is important. Interestingly, this kind of structured walkthrough is pretty informal. And whenever I ask this question in class and ask students, why do you think it's informal? And I've never yet had a student come up to me and say, I know why it's informal. Because what it is, it's all about building confidence and in the programmer's ability to build code, okay? You don't want a programmer when you have all the peers, all his fellow programmers looking at his or her code, going, oh, this is wrong. Oh no, that's not good. Oh, this is not very good. Oh dear. You know, you don't want to make your programmers unhappy. You don't want to piss them off, right? You don't want to make them too apprehensive, okay? The other thing about this is that you want to do these walkthroughs regularly. You know, the longer you leave a walkthrough to go through code, the more code you've got to go through, the more deficiencies you're probably going to come across, probably more defensive as a result, the programmer whose code is being reviewed is going to become, all right? Because more and more problems are going to be found if you review bigger and bigger pieces of code. That's just the nature of of the size of it, right? So it's informal, it's done regularly, and it allows for growth and perhaps support be given to the individual programmer to make sure that the number of problems that are being found are reduced. So we're trying to find the errors. We're not trying to correct them, we're trying to find them. Okay, the programmer is going to correct the errors that have been found by their colleagues. Okay, so the programmer's job of the code that he or she has written and which is being reviewed by his or her peers, they've got to fix it. Okay, so this structured walkthrough is done by team members. If you look at figure 13-2 on page 459, you'll see for more details. The next level of testing is called a desk check. Okay, so programming code is sequentially executed manually by the reviewer using test cases. Okay, so again, what the code does is important. We're going to execute the code sequentially. So we're going to build up and build up and build up. Again, this is an informal process, and the programmer is going to work through codes using these test cases. What is a test case? Here we have it, a specific scenario of transactions, queries, or navigation paths, okay? So it can be typical, can be critical, can be abnormal even. We might want to have kind of like the weird, crazy test cases that the chances of you having to execute against would be very, very small, but we still want to consider those just in case, okay? So each revision of software, we're going to keep on doing these test cases. We're going to document any differences, any delta from what we expect to what we actually get. And we're also going to include, as I say, illegal and out of range data, okay? So we're executing each instruction as a result. So we're doing all this code, it's being sequentially executed, okay? We're next going to go to unit testing, which is where we test modules, each individual modules to discover error in the code. So a module is a software component or part of a program that contains more than one routine, okay? So you add lots of modules together and you get a program. So now we're testing modules, okay? We're testing individual modules to discover any errors in the code, okay? It's also known as module testing. This is an automated technique. We also, not only are we testing modules alone, we're also, we can also use this to test with other modules as well. When we're doing that, we might use this thing called stub testing. Now, stub testing is like a dummy kind of border we put in place to replicate with things called subordinate modules. So if I have a module, this kind of area, the software component of a program that calls on other modules or subordinate modules, then instead of going through each individual subordinate modules, we can put this dummy control in place called a stub, which takes the place of all the subordinate modules, which allows us just to test the main module part that we want to test. So stub testing, we put in a few lines of code to substitute for subordinate modules. Okay, so the coordinate module calls the stub instead of the subordinate module. The stub accepts the control and returns it, and it's very easy to do. Once we've done unit testing, we might go then into what we call integration testing. And integration testing is where we integrate the multiple modules in a program for testing. So we'll start with our main modules, go down top down and incremental. And as you can see here, it's a very gradual process. So we very slowly build up. We build up. So we've tested each module independently of each other. We've used stub tests. We've kind of checked the program. We've done unit tests and walkthroughs and so on and so forth. And now we're starting to test modules together. So we might have a coordinating module, a main module in the program, and the subordinate modules. After the first term, we're going to add more modules on and slowly build up and slowly build up and slowly build up. And it will keep on going until the whole program has been tested as a unit. And then we might have a whole program, and then we can sign off on a program in of itself. But then we might have to go to system testing. So the whole system, we might have multiple programs. So system testing is this process of bringing together all the programs in a system for testing. And again, typically top down and incremental. Okay, and again, it's very similar to integration testing in the module level, but integrates programs into systems processes. It's just the next level up. So the purpose of system testing, demonstrate whether the system meets its objectives. So we're not using live data. That's the point to make, right? So we're using data we're using beta data. what's the word I'm looking for? Dummy data. Yeah, we're using test data, okay? So we're using test data. It's going to be similar, but we're not actually using real live data yet, because we need to get that level of confidence that everything's good before we take that next step, okay? So after testing, all the code that works may be integrated at the end of each working day. And the working version of the system could very well be released frequently, okay? And as I said, large organizations have dedicated testing staff. So what we have is this concept of refactoring. So if I have regular testing and regular releases, as I say, could be very, very frequently, all right? You might be doing integrations each day with previous software and then doing releases every week. I might have this thing called refactoring, okay? So as you add features, systems become inherently more complicated because the new features are being added. So what we might want to do is refactor our code, all right? So we might want to simplify our complex statements. We might want to abstract solutions using reusable code. We might want to remove duplicated code. Do you remember we've spoken about extreme programming? This is very common when you see refactoring with extreme programming, when you have two programmers working together and they bounce ideas off each other, and because they work so effectively, you can get very quick turnaround of new software code. So refactoring is this kind of combination of coding and testing and releases all in one go, working often commonly in extreme programming. Now, when it comes to what we call acceptance testing, this is where testers are the user community who are going to use the system, and they go through this process of signing off. All right, so we're not yet using real live data, and we may not yet have used our actual user community who are going to be using the system. So acceptance testing or user acceptance testing, you often hear the phrase UAT. That's what we used to know it in my world, UAT, user acceptance testing. This is the process in which the actual users who are going to use the system test it, okay? So making sure that the system meets the requirements of their needs, okay? And it will depend, if you're a very small organization versus the 230,000 of Bank of America, you can obviously understand the testing needs and approaches are going to be very, very different. Now, when it comes to UAT, to user acceptance testing, there are two types of testing. We have alpha testing and beta testing. Alpha testing is this user testing of a completed information system using simulated data, and beta testing is using real data in a real user environment. So beta testing is pretty much the real thing, but again, you won't use a massive bit of critical, important, let's say it's an environment for banking. You're not going to put a massive trade using beta testing. You're going to use live data, and you're going to use a real live user, but they're not going to use really mission critical data in that context. So alpha testing used user testing of a completed IS using simulated data, and beta testing, user testing of completed IS using real data in the real user environment. Let's look at these in a little bit more detail. So alpha testing, what does it say? This is our dedicated test environment. So recovery testing, that's something you're going to have to do. Forces the software environment to fail to verify that recovery is properly performed. Yeah. Security testing, that everything all our secure is going to protect our information system from improper access. Very important. We're going to try and break the system. Stress testing, and our performance testing, determine how the system performs in the range of possible environments in which it may be used. So maybe using different hardware configurations, different networks, different operating systems from a performance testing perspective. So an alpha test type will be using, an alpha test type, we're using a dedicated test environment. So beta testing, next to beta testing, so a subset of intended users run the system. Typically, you've got to get a friendly user, because nobody really wants to do this. I'll tell you now, getting a user to come volunteer to do this is a real pain because nobody wants to do it. So you're going to make sure that everything works as intended. It's kind of like a rehearsal of the go live of actually implementing the new system. And any problems here, you're going to have them created, not created, configured and fixed before you go live, before the users will actually use the system. So let's assume that all that testing, all that myriad of different testing, from building up from the very smallest component parts, all that testing we did back in the day, unit testing, inspections and walkthroughs and desk checks, integration testing and system testing using stubs. And we brought all our modules together and we've done our alpha testing, we've done our beta testing, and everything's gone fine. What's the next step? Let's do our installation. Okay. The installation is this process of changing from the current information system environment to a new one. So when we go from the installation phase, we're cutting over to our new world. There are 4 broad strategies that we might want to consider: direct, parallel, single location, and phased. And as I said at the beginning of the class, each of these have their pros and each of these have their challenges. So there's no right answer to which one is the most appropriate, but you need to understand what the differences between these different strategies are. Let's look at these in turn, beginning with direct. So direct, what's it say? Changing over from the old system to a new one by turning off the old system when the new system is turned on. Also known as cold turkey, and as you could well expect, could be very, very risky. Okay, so you need to have a whole brand new system on. You've got to have a lot of confidence. You're going to hope, right? So here's a question for you. When do you think you would typically do a direct installation? What part of the week? I'll tell you, it's actually, you do it on a Friday evening. You do it on a Friday evening because you want to have the whole of the weekend to back it out when people aren't working there typically, so that if you do have problems, you've got time to back it out and to get back to the old environment, and then you have time to fix the problems. So in this environment, you have a current system, you build a new system, and then you suddenly go cold turkey, you turn off the old system, you turn on the new system, and away you go. As you could well believe, it's the least expensive, it's probably the quickest changeover process, but it is the most risky. So the users are certainly at the mercy of the new system. It could pretty well be the only choice you've got if you think that both the old and the new systems cannot exist together at the same time. And that could well be the case if you don't want to have confusion, okay? If you don't want your users getting confused about which system they're actually using, whether it's the old one or the new one, then a direct installation may be the only choice that you've got. Alternatively, you might want to go for a parallel installation, okay? What's this say? Running the old information system and the new one at the same time until management decides that the old system can be turned off. It's less risky, okay, because you're going to have 2 systems running together in parallel. And as you slowly move users across, you're going to hopefully not have any confusion for a user community about which system they're actually using. It's going to be less risky. It's going to be more expensive because you're going to have 2 systems you're going to have to support at the same time. And as I say, you can have possible delays until the new system is completely ready. So it kind of, again, it has its pros, it has its cons. It depends on what's the risk appetite and the culture and the historical interaction, the politics of the environment in which you're doing it. So we had direct, we have parallel. The next one is for a multi-location organization. And this one is called a single location installation. So here's what you do is you basically take one of your sites, typically one of your less important sites, and you see how it goes. You do a release. You might do a direct release in that location, and you see how it goes just to that one location. And if you can have it working there seamlessly, then that builds the confidence that if you roll out this location, sorry, this release, this new system in other locations, then it's going to work. So a single location installation is trying out an information system at one site and using experience to decide if and how the new system should be deployed throughout the organization. So when I was working in the banks, I always used to do my releases in Zurich. We had a very small office in Zurich where we had 6 users, 6 traders who would do things for there, and they had their own very small versions of the systems. So we would always use them as a single local installation to do it before anybody else. And assuming all went fine, then we had the confidence that that system rollout would be best for all the other locations. You think about London, where we might have, I don't know, 300 users using a single system versus 6. You can see if there's a problem, you only want to impact 6 users in a non-important environment versus 300 in a very important environment. So single location installation, also known as a location installation or a pilot installation, it's kind of like the best of both worlds between the parallel and direct. Okay, so if things go badly, you're going to limit the damage, but it does mean that you're going to have your staff trying to support two versions of the system in a single location. And it does mean that the system won't be rolled out as quickly as with Direct. And you might have a whole system installed, but some part of the organizations won't get the benefit until you've absolutely signed us off. So this is like a staged location. The last phase is a thing called, here we have the single location installation, another sort of follow-up thing. So location 1, location 2, you have a current system, you install your new system, you swap over to your new system in a direct move. And at your location 2, you carry on, you get the confidence, you install your new system, and you do the same as well. A phased installation is the slowest of them all, right? And this is where we spread our risk over time and place. And essentially, what is it? It's changing from the old information system to the new one, very slowly, very incrementally, starting with components of the system, and then gradually extending the installation to cover the whole system. This is also known as a staged installation. So we've got to have our old systems in place, we've got to have our new systems in place, they've got to coexist, they've got to share data. You're going to use bridge programs to connect the old and new databases and programs. You've got to have very careful version control, lots of conversions at each phase. It's going to take a long time, it's going to be very expensive, but you're not going to have as much risk. So here we have your current system, you're going to have your new system where you're going to install the new module 1 after you've installed a module 1 on your current system, and then you're going to switch over to your new system. Your current system is going to have module 1 replaced, and so on and so forth. So essentially, you swap over module component parts of each of your system. So it takes much longer, it's less risky. I've never used this because it can get so confusing. Because you've got to make sure that all of your support and your implementation teams and everything understand exactly, and your user communities understand exactly which module is being located where and when and how it's being cut across and when it's being cut across. It's just, I would never ever use it if I could possibly do this approach. Okay, so we have those 4 approaches to installation. So we have some factors that we need to think about which influence our installation. And we have so we call them installation planning factors. We have our data conversion, our planned system shutdown, and our business cycles. So these are, all you need to know that these are our planning factors that will influence which installation we will probably be following, which would make the most sense. We also spoke about earlier on about the need for documentation. Okay, so documentation. Documentation, as we all know, is one of those factors which are always, always, always overlooked, and you shouldn't. You really cannot. Okay, the ability to document well and the interest and the relevance of documentation is absolutely dependent on the life cycle and the importance of documentation to the organization. Typically, there are 2 types of documentation, as you can see on the screen: system documentation and user documentation. From a system documentation perspective, we have, if you look at table 13-5 on page 468, you'll see a very good breakdown of the documentation there. So system documentation, what is that? Detailed information about a system's design specifications, internal workings, and functionality. In this context, we have internal and external. So internal is source code or documentation is generated when the source code is being compiled. External documentation is the things like the structured diagramming techniques, the data flow diagrams, etc., and so on and so forth, the entity relationship diagrams. So this system documentation is what you would give to your system administrators, the people who are going to support the system after the system's gone live. And then user documentation to give to your user community who are going to use that system about what the system is, how it works, how to use it. So we have system documentation for the people who are going to, the techies who are going to look after the system, and user documentation for the users who are going to use the system. From a user documentation perspective, there are 6 component parts that you'd probably write about. You're going to have a guide on how users can use the system to perform specific tasks, a reference guide, this is the system's functions and commands, a QRG, a quick reference guide, essential information, very short, very concise about operating a system. Releases, release description. what's getting released in what release, and what features are being released, and what enhancements can they expect, and known challenges and problems and how they've been dealt with, and so on and so forth. A system administrator's guide, the process of documentation of acceptance. It allows users to test with proper system installation and signify acceptance of their signatures. All these are different types of user documentation, and you will look to provide all of it. It's very, very important. What about training users? Oh man, yeah, training users. That's often overlooked. You just kind of leave your users to get on with it, right? It's frustrating. Training users, it's often neglected. Um, it kind of, what training do you need to give them? It kind of depends on the type of system and the user expertise. So maybe you would train them on any of the following things, like how to use a system, some of general computer concepts, information system concepts, organization concepts, systems management, systems installation. You know, some of these topics, it's all going to depend. Um, you will have to kind of look at it depending on your user community and determine which training in each of these areas would be most useful. So you might have, in that context, you might have dedicated trainers who are there to teach your users how to use a system. That's very useful. You might have classrooms, you might have distance learning, you might have a bit of both of instructor and learning, you might have software help components, external sources, and so on and so forth. Typically, it depends on the size of the organization and the importance given to users. Support as well, support. So support, it kind of ties in into maintenance as well. Support is providing ongoing educational and problem-solving assistance to our users. It's very important, often inadequate, typically expensive, takes a lot of time. If you're a vendor, you're going to be charging a lot of money to the organization you're providing support for. It's going to be a very good money maker. It can be automated. In my experience, the banks always made sure that they have wonderful, outstanding support teams who are dedicated support of users from an application and infrastructure perspective, just in case. You can't risk compromising that perspective. And that's what I did for many years. I worked in application support and desktop and Windows and operations and infrastructure support and server support as well. Very, very important.